This video is for experiment 4, which is the Titrimetric Determination of Equilibrium. So before, I know this is a little late now, but before you came to lab, you were supposed to do 2 calculations. So not everybody got this one right, so I'm just going to explain right now how to do them in case you weren't sure or mixed something up. So if you are asked to make a 1 molar solution of sodium hydroxide, and this is the volume you need to make, which is 0.250 liters of sodium hydroxide, and it's 1 mole per liter. So molarity is moles per liter, so you're making 0.25 liters times the molarity, which is 1 mole per liter. So that's going to equal 0.25 moles of sodium hydroxide that we need to weigh out. And to get to the mass of that, so to find the grams, you take the 0.25 moles of sodium hydroxide, multiply it times the molecular weight. Some of you divided by 40, but you want the moles to cancel out here. Moles to cancel out to get you 10 grams of sodium hydroxide. Okay, so for part B, you had to figure out the grams of the KHP or the K2, whatever the formula was. So it was asking if you use 20 mils of 1 molar sodium hydroxide, how much KHP is that? So you would take 20 mils and then convert it to liters times the molarity of the concentration, and that would be using 0.02 moles of sodium hydroxide. And it's a 1-to-1 mole ratio. So 0.02 moles of sodium hydroxide equals 1 mole of KHP over 1 mole of NaOH, and these things cancel out. And then you end up with 0.020 moles of KHP. And to determine the grams, you're just going to multiply that times the molecular weight of KHP. Again, the moles of KHP are going to cancel out, and you're left with 4.08 grams of KHP to measure the mass of. So in the lab, you have your data. It may not look exactly like this laid out, but here's the mass of the KHP for each of the trials, and then the initial volumes and the final volumes on your readings for each of the trials when you did your titrations. And then I just calculated the total volume that was used by subtracting the 0.43 from 19.15. So you have these numbers here, and then here I just converted it to liters so that I wouldn't have to do that later. So for part D, your data may look like this. You have 5 mils of the 3 molar-ish HCl, and then you have the initial volumes, and then here again, total volume. I didn't calculate it into liters yet, but I'll do that later. Okay, so for calculations for part B, you need to calculate the molarity of NaOH. So you have to determine the number of moles of KHP that was used for each trial. And so you have the mass of KHP. So for my first trial, it's 4.073 grams. And then you're going to just divide it now by the grams of KHP, the molecular weight. So these cancel out. You're left with moles. And this one comes out to 0.01994 moles of KHP. This is in a 1-to-1 mole ratio, so that equals 0.01994 moles of NaOH. Here we have the second trial. This is 0.01998. And I'm just going to write NaOH here, moles of NaOH. And then this one is 0.01997 moles KHP equals moles NaOH. Okay, so then the reaction again of KHP with NaOH is 1-to-1. So 1 mole KHP equals 1 mole NaOH. So that's what I meant by here. Those are all equal to each other. So to determine the concentration of sodium hydroxide, this was for the trial 1, how many moles of sodium hydroxide was used. So I can take that divided by the volume of sodium hydroxide that I titrated in liters, and that will equal the molarity of NaOH in moles per liter. So for trial 1, it was 0.01994 moles, which came from up here, divided by the 0.1872 liters. And that was the first trial total volume here in liters. So this comes out to my molarity being 1.065 molar. This one, 0.01998, again, that came from this value here, divided by the 19.02 in liters. and this is 1.050. And this last one is 1.051 molar. If you're not familiar with how to calculate average, you can look in Appendix A at the end in data analysis. But the average is just the sum of your values divided by how many values there were. So I have these 3 molarities divided by 3 because there was 3 readings. So my average comes out to 1.055 molar. So that's the average concentration for the sodium hydroxide. To do the standard deviation, the deviation for one value equals the average minus the value measured. So for D1, I have the average 1.055 minus the first value, 0.01. For the second, okay, so that's all of the D values. And then standard deviation is the square root of the sum of the D squared minus N minus 1, so it'd be 3 minus 1 here. So I have each of these broken down so you just know what is going on. So 0.01 squared, 0.005 squared, all of those squared over 3 minus 1, and then you take the squared root of that. So again, this is just written out. So that comes down to, this is 0.000141 over 2, and then the square root of that ends up being 0.0084. And then for the RSD, you take the standard deviation divided by your concentration times 100, and my RSD was 0.796%. So I think that's, oh no, I have more calculations. Sorry about that, jumped the gun there. Okay, so for part E, to determine the calculations for the HCl, you want to use the molarity of sodium hydroxide, which we just determined was 1.055 moles per liter. And to get to the moles of HCl, you want to determine how much NaOH you use. So for trial 1, I had 16.01 mils times this concentration. This is 0.01689 moles. For trial 2, I used 16.42 mils, so that ends up being 0.01732 moles. And trial 3 was 0.01682 moles. So that was of NaOH. There's the moles of NaOH equals moles of HCl, so this is equal to the moles of HCl as well. Okay, so then to get the concentration of HCl, the molarity of HCl is moles of HCl over volume. So we have these moles, and we titrated 5 milliliters, which is 5.005 liters. So you would take the 16.89 from up here, divided by the 0.005 to get 3.378 molar. This is 3.464 molar, and this is 3.364. And then for the average, again, just all of the values added up divided by 3. This comes to 3.402 molar. All right, and that is definitely the end of the calculations.